Okay, so today we're going to be finishing up chapter 1. So, chapter 1 is just a lot of introductions to topics that we're going to go over in more depth in this class. So, today, we're first going to have a review on what we went over in week 2. And then we're going to go over plotting a bit towards the end of chapter 1. And then we're going to start chapter 2, which is on arrays. So there was some questions on the homework. So in the homework, you're going to be typing in your code in Matlab. So, whatever code that you need to solve a problem, and then you're going to copy and paste your code into a Word document, and then you're going to save that as a PDF and then submit that to Canvas. So, for this line here, let's say I had a question where you had to define a vector. All you have to do is submit this code. So that's all I would want to see. I don't need to see the output. So, some of you have submitted like all of this, and that's okay. But for homeworks in the future, I would rather just see the code, because if you include the output, it gets pretty cluttered. And then to submit the homework, I know some of you already have submitted it. But all you have to do, go to assignments, and then click on homework 1.
I submitted it as PDF. Do you want me to change that?
No, I do want it as a PDF.
Oh, okay. They
Yeah.
said Word doc.
Yeah, well, I'm just guessing some of you are going into Microsoft Word and then you save it as a PDF.
Okay, thank you.
Okay, and then submit assignment, and then obviously just submit your PDF. In fact, I restricted this to only allow PDF submission. Okay, let's move on. Okay, so before we get started on new stuff today, we're going to have a review exercise, so that's going to be pretty standard. Oh my god. Okay, so week 3. So we're going to finish up Intro to Matlab, and then we're going to start Chapter 2, which is Arrays. If you want to look at the slides for that, I uploaded those last night as well. Okay, so last week we went over defining vectors and making matrices. We went over how to make an evenly spaced array or vector. So there's 2 methods. One of them was using the colon operator. So we can do something like a equals 1. So we'll start at 1. Our step size we can put as 1. And then we'll go to a value of 10. So that's one method. And then the other method is using the Linspace command. So I could do Linspace. Let's say I want to start at 1. I want to end at 10. And let's say that I want to have a length of 10. So I could do it that way too. Then we went over the length command and the numel command. So length, that will look at the number of elements in a vector. So if we look at, let's say, vector b, I could type in a length of b. We'll get an answer of 10. And then the numel function will give us the number of elements in a vector. So if we're using the length command and the numel command for a vector, both of them will give the same output. If we do it for a matrix, so let's make a matrix here. I'll do, 303, 222. So if we have this matrix A and I use the length command, this will give us an answer of 3. So for a matrix, if we use the length command, it's going to look at which dimension has a higher number of elements. So we have 2 rows and we have 3 columns. So we have more columns than rows. So Matlab will say, okay, I'm going to look at the number of columns that you have in this matrix, and I'm going to tell you how many columns you have. So in this case, that's 3. If I use the numel command for a matrix, that'll give us the kind of the absolute value for how many elements are in that matrix. So in this case, it'll be 6, because we have 1, 2, 3, 4, 5, 6 values. Okay, and then finding a value at a specific index in a vector. So let's look at our vector A here. If I want to say find or give me the value for the fifth element in this vector, I can type in A. So that's our vector. And then in parentheses, I'll put the index that I want to look at. So if I put A and then in parentheses 5, Matlab will look at the fifth element in this vector A and give us the output. So in this case, it'll be 5. And then with a matrix too, we can actually do it with a matrix as well. So if I type in A, let's say 3, we get an answer of 0. So if we have a matrix, it goes kind of column by column. So we start out at 1, then we go to 2, and then we go to 3. But how we reference or use array addressing is what it's called. For matrices, we'll typically actually specify the specific row and the specific column. So we're going to go over that later today once we start chapter 2. And then the last thing we went over last time was going over polynomials. So to define a polynomial, we can just do a equals, I don't know, 5, 3, 2. So really you just define a row vector again. But it stands for a polynomial. So in this case, we would have 5x squared plus 3x plus 2. Okay, so that's what we did last time. And let's do a little review. So it's kind of similar to the stuff I just showed you guys, but I'll give you a minute to work on this, and then we'll make sure that everyone got it right, and then we'll start some new stuff.
I forgot. Is the zero? Is the first element index 0?
The first element?
Yeah. Is it index 0 or is it index 1?
Oh, it's 1. Yeah.
Okay.
Yeah, for MATLAB, it starts at 1. Okay, so that should be enough time. So let's go over this stuff now. So first one, we got to make a vector b that goes from -5 to 15, and we're going to have a step size of 0.01. So for this, we can use the colon operator. So I'll do b equals -5. We're going to put a colon, and then we're going to put our step size, so 0.01, and then we're going to go to 15. Okay, I'm going to suppress it with a semicolon. And here's b, so we start at -5. And let's make sure our last value is 15. Okay, well, you saw it for a second. There it is, 15. Okay, and then we're going to make a vector A that goes from 13, that's the first value, to 967, and it has 232 elements. So there's some weird numbers here, so looking at this off the bat, I don't know what the step size is. Since I don't know the step size, I'm going to use the Linspace command. So I'll do A equals Linspace 13, that's going to be the first number that we start at. Then we want to go to 967, and the length or the amount of elements that we have in this vector is going to be 232. Okay, and then we see that right here in our workspace. So we want to find the value of the 17th element. So I'll do A, and then in parentheses 17. Let's double check this. So I'll open up the vector, and I'll look at the 17th element, and we see that these values correspond. Now, it looks a little different. That's just because of the format options that we have. Okay, and then we want to write code to find how many elements are in each vector. So we just went over that, but let's do numel of b, and then we can do numel of a, and then we get the length for each vector. I could have used the length command as well. Okay, so any questions on the review? Oh yeah, and then can we add these? No, we can't add them because the length for each vector is different. Okay, should be a pretty simple review.
Can you append elements into arrays?
Yeah, we're actually going to go over that once we start arrays.
Okay.
Okay, so before we get to chapter 2, we have a few more things to go over. So all of this, remember, is just intro. So we're going to go over linear algebra maybe later on in the semester if we have more time. But so far when we've done division, we've done a /, and that's kind of our normal everyday division. If we do a /, that's going to be left-hand division. So left-hand division, that'll be to solve a system of equations. So you see in my slide here, I kind of drew, or I took a picture of a system of equations, and we can use Matlab to solve for this. So this isn't a math class, so I won't go over the theory of how to solve for it by hand, but I'll show you how we can solve it inside of Matlab. So looking at this system of equations here, we're going to first make a matrix A, which will be everything that we have on the left-hand side here of the equal signs. So I'll do A equals 6. I'm going to go row by row. So we have 6, 12, 4. Then I put a semicolon to go on a new row. I'll put 7, -2, 3. And then another semicolon. We're on the third row now. I'll put 2, 8, and then -9. Okay, so there's our matrix A. And now we're going to make a column vector that will have all the values that are on the right-hand side of the equal sign. So I'll do B equals 70, put a semicolon, 5, put a semicolon, and then 64. Okay, and then here's our column vector. And if we want to solve for x, y, and z, we're going to use our backhand or our /, which is left-hand division, and we can solve for all of those coefficients. So what we have to do is a /b, and then we get our answer. So basically x would be equal to 3, y would be equal to 5, and z would be equal to -2. So if you're doing like linear algebra, if you're taking that class, or if you're taking that class and you're doing some problems where you have to solve these system of equations, you can use Matlab to check your work, make sure you got your answer right. Or later on, when you take other classes, often we'll have like a differential equation that we are, maybe we're modeling the motion of something with a differential equation. You can convert that into a linear system of equations, and then you can solve for that with Matlab, and you can very quickly solve complex systems using this kind of method instead of solving for it analytically. So there is a lot of good use for it.
Patrick.
Mm-hmm.
Patrick. So for how did you make the for the division? How did you make it other way around? Like yeah. No, capital A and B.
Mm-hmm.
Go underneath. Okay.
This one?
How did you do it?
Oh, I just put in A and then a /B.
How'd you do the /?
It's just on your keyboard right above the enter key.
Yeah, I can't do wait.
You got it?
No, I can't find it.
The / should be right above your enter key.
Right above the enter key. Oh, yeah. Okay, found it. Okay.
Yeah.
Alright, thanks.
Mm-hmm. Yeah, easier than elementary row operations. Yeah, it's been a while since I took that class. If I had to do that right now, I probably couldn't do it, or I'd need to refresh myself. Okay, making a script file. So this we went over last time, and this is kind of what we'll continue to do from here on out, just so we can save all of our work, throughout class, and we can reference it later on. So I'm not going to go over these slides again since we did that at the end of last class, but if you need a little refresher, to make a script file, we just go up here or in the Home tab and click on New Script. Okay, and then your script file will be in this editor window here. Okay, so Matlab has some debugging built in, so this will just be one slide. We'll go over debugging in more depth later on. And that's like, I don't know, chapter 5 or something. So let's do, if I type in A, I'm going to get an error right now because I haven't defined that variable yet. So, okay, I'll put in A and then I'm going to run the script. So first I need to save it. So I'll go to Save As. And I don't know, I'll call this Chapter 1, Week 3. Okay, so I'll save it and then I'll press Run. And then you see in my command window, I have an error message. It says unrecognized function or variable A. And it'll even give me the line number where this error occurs. So Matlab is pretty good with their error messages for the most part. They will often, give you at least their best guess at what went wrong in your script. So if you have a syntax error or maybe you forgot a parentheses, it'll tell you which line that the error occurred on and most likely what's gone wrong. So more in-depth debugging, again, we're going to go over that later on in like chapter 5. And that debugging will kind of look at these tools up here where it says run in advance and run section. So once we get to there, we can actually go kind of line by line or section by section to make sure that our code is running correctly. So once we start writing longer scripts, these tools will be of more use to us.
Patrick, when I open my script, it says if I want to open it as a live script.
Okay, yeah, I think a live script is mostly for like actually giving a lecture. So, I'm not using one, but you probably clicked on this one right here to the right.
Oh, okay, yeah.
Yeah, so just click on, make sure you're in the top left on New Script.
Okay, for sure. Thank you.
Mm-hmm.
For the homework, do we need to run it on a script or do we just run it on a command window?
You could have done either or. So if you did it in the command window, just make sure that you didn't, lose your work, that you copy and pasted it in a Word doc right away.
Okay. All right. Thank you.
Mm-hmm. But yeah, since we've gone over how to make a script file, I would recommend always using a script file from here on out. All right, so we're going to go over plotting now, which I think is, if we're saying anything is fun for MATLAB, I think plotting is probably the most fun. Because you can actually see stuff, which will be what we do for our project once we get to that too. Okay, so once we actually go over plotting for that chapter, that'll probably take really 2 or 3 weeks to go over because there's a lot of options for plotting. So when we make a plot, we have to make sure that both our independent and our dependent variable are the same length. So if I have a vector x and a vector y, the length or the number of elements for those vectors have to be the same length. Because if I have some, x value, I need to have a corresponding y value for that point. Okay, so let's make a plot right now. So I'm gonna go in our script here, and I'm gonna start out our script by putting in a comment, just so I know when I look back at the script at some other point, I know what's going on here. So I don't know, I'll do EGME 205, week 3, intro to MATLAB, and arrays. All right, and then I'll put, after this, I'm always going to start out my script with these two lines here, clear and then CLC. So if I have any variable that's in my workspace right now, let's say I was in another script or I was doing stuff in the command window here. So I just defined a variable a is equal to 2. If I'm running this script, I probably, I don't want this variable right now if I was going to run this script. So because of that, I'm going to start out the script by running the clear command. So that'll clear out the workspace, and then we're going to run the CLC command. That'll clear out the text in the command window. And then Matlab will start to run every other line that's in our script, which we want to store in our memory once we run that code. So if I run the code now, our workspace is going to clear out. Okay, so basically, whenever you make a script, make sure that at the very top of your script, you have these two lines of code. Okay, so let's work on our first plot here. So first off, we're going to make an X domain. So, if you're, if you want like a more real world example, that might be like a time domain. So let's say that we're plotting the motion of some object over time. The x-axis would have all of our time kind of data stored in there. So I'll start this out by making a section. So to make a section, we have 2% signs. I'll call this plot example. Okay, so let's make our x domain. We're going to make a vector x. We're going to start at 0. Let's use a step size of 0.5. And our last value will be 10. Okay, and then we are going to make our dependent variable, which will be y. And for this, we can do 5 times cosine of 3 times x. So we have 5 cosine 3x. Okay, so right now I can run my script, and when I run my script, it also saves the script at the same time. Okay, so I ran it, pressed F5, or you can click on the editor tab up top here, and then click on run. Okay, so I ran my script, so I see I have my x variable and my y variable, and they both have the same length. So they both have the same length since y was a function of x. So because it's a function of x, it has to be the same length as x. Okay, so to plot this now, we're going to use the plot command. So pretty intuitive, right? So we're going to say plot, and then our first argument is going to be the x data that we want to plot. So I'm going to put in x, and then we're going to specify the y data that we want to plot. So that's going to be y. Okay, so if I just do this right now, and I run my script, then we have our plot here. Okay, so we have our cosine kind of wave here. So it looks pretty terrible, right? It's really jagged, and it just looks bad. So if I saw this, I would be disappointed. So let's make it look a bit better. First off, if I want to change the color of this, so by default, Matlab uses blue. So if I want to change the color of this plot, after I plot my x variable and my y variable, I'll put in another comma. And then in apostrophes, I'm going to specify the kind of color that I want. So if I want red, I'm going to put in R. Then I can run this, and now our plot is in red. If I want like cyan, I can put C. I can run this, and we have cyan. If I want green, I'll put a G.
Black. What do you do if you want black?
Black is K. Kind of weird. But B
And
is
blue is B.
Yeah.
How about
Okay,
brown?
Brown, no idea off the top of my head. So you can, for that, you can look at the documentation, and they'll tell you all of the possible colors that we have. So if I go here, now I usually Google the stuff instead. So I'll do Matlab line colors. So they only have a few that are kind of defined like we were just doing, where we put just some letter. And yeah, that's all right here. So brown actually isn't even in there. So if you wanted to find brown, you would have to actually define the RGB value. So
I see.
yeah, so and then we'll go over that once we actually go in the plotting chapter.
All right.
Okay. And then one more thing, just since it's in my slide, and we're going to go over line markers in more depth later on too. If I want to make this like black circles, I could put KO, and now I have black circles here. And now it's also a scatter plot though, so it's a lot harder to read for this particular data because we're plotting a cosine wave. This looks terrible. We don't really know what's going on. So if I want circles,
Increase
but I
the
also
steps, right?
Hmm?
So you just increase the amount of steps, or decrease the step
Yeah.
width to make it look better, right?
Yeah, you can do that too. Yeah. But if I want to also have a line, I can just put in a dash. And now I can see the intervals that we have. So each step size here. And then I can also connect it with this line by putting in a dash. Okay, and then as for the step size, which is a good point, this looks very jagged right now because we only have 21 elements for these vectors that we defined. So if we decrease the step size, we can make it a lot smoother. So I'll change this from a step size of 0.5 to like 0.01. And now it looks like this. It also looks terrible right now, but that's because I have circles for every single value that we have. So I'm going to take out the circles now, and I'll just have a black line. And there we go. So this looks a lot better. So we have 10,000 elements right now, 10,001. Okay, I'll also throw on one more thing. I personally feel like by default the line width here is always too thin, so we can change the line width by typing in line width. And then we can put in either 1.5 or 2, or you can put anything you want, but I think 1.5 or 2 usually looks best. And make sure your capitalization is the same as I have here. Alright. Okay, so I'm going to give you guys a little exercise to work on now for plotting. And then after this, we're going to go on to chapter 2. Okay, so first off, you're going to create an X domain from 0 to 10, and we'll use a step size of 0.5. And then after that, we're going to change the step size to make it smooth again. And then your dependent variable y is going to be e to the negative x times cosine of 2 pi x. Okay, so I'll give you a minute or two to work on that, and then you want to plot it as well. Hey Nathan, you know your mic is on, right?
Oh, sorry.
It's okay. Just want to let you know. Alright, I'll give you guys a few more seconds and then we'll go over it. Okay, so since we're in our script file, I can just make a whole new section here. So I'll say plot exercise. And then we can work on this now. So we want to first make an X domain from 0 to 10 with a step size of 0.5. So I can put in x equals 0, 0. We want 0.5 for our step size, and then we're going to go to 10. So you see I have x defined up here, and then I have x defined right here. So when we run our script, Matlab kind of goes line by line. So it's basically going to overwrite what we had defined on line 7. So basically, this entire plot is going to be generated in MATLAB, and then it's going to go on to the next line, which will be down here, and it will do this, and then, really we're going to make a whole new plot here, which will overwrite the plot that we made up here. And then I'll show you how to actually save, how to kind of write your script so you can have both plots show up at the same time as well. Okay, so let's define y. So we have e to the negative x. So to put in e, we need to type in exp for exponential, and then we'll put in x. We want negative x, and then we're going to do times cosine of 2 times pi x. So I kind of threw you a curveball. I forgot I actually had this. This is from, I made all these slides last semester, and I forgot that I threw in this curveball. So if you did times cosine of 2 times pi times x, you get an error. So it says incorrect dimensions for matrix multiplication. Check that the number of columns in the first matrix matches the number of rows in the second matrix. To perform element-wise multiplication, we have to put in a dot and then a star. So probably an unfair thing that I did here actually. But we have this error because first Matlab was trying to do matrix multiplication. And the number of columns in the first array that we have doesn't match the number of rows in the other array, or it's trying to look that we have two matrices defined here. But of course we have vectors and not a matrix. So Matlab is first guessing that that's what we were trying to do. In this case we're not though. We're actually just multiplying a vector. But to do this, we have to multiply this element by element. So we're going to talk about this in a lot of depth in chapter 2. So again, kind of an unfair example really that I just gave you. But for now, just trust me that we need to put in a period and a star. And then if we run our code, it'll actually run correctly. So this is called element by element multiplication. So we have our vector x on the left here, and our vector x appears again on the right. So I want to basically multiply each element in those vectors, kind of go element by element. Okay, and then we can use our plot command again, which is just plot x comma y. So now if I run this, I'm only going to have one plot, and it's the plot that we just made right now for this new function here, e to the negative x times cosine of 2 times pi times x. So it looks like crap again, so let's fix it. I'm going to change the step size to be 0.01. And I don't know, let's make this green. And in this case, I only put green. I didn't put a dash, but this will still be a line. So if I put in G and a dash, the same thing is going to show up. And then I'll make the line width 1.5. Okay, let's run this now. And there we go. We have our green plot here. So if I want to save both plots at the same time, basically run our script and have both of them show up, we can do that as well. So right now Matlab is overwriting this plot here once it gets to the code at the bottom. So to fix this, we have to basically assign a figure number for each plot. So we use the figure command, and in this case I'll call this figure 1, and then down here I'll call this figure 2. So now if I run our code, we get both plots showing up once we run the code.
How do you get to show both on the same graph?
Yeah, good question. So for that, we would have to use a command called hold on. So let's actually do that. I can actually put it right here. So I'm going to type in hold on, and that tells MATLAB, hold on. I want to plot some more stuff on this graph. So we can then put in whatever we want to plot. And then once we're done, we type in hold off. And now if I run this, then we get both on the same graph.
All right, thanks.
Okay, so any other questions before we get on to chapter 2? Okay. So, basically a little summary of what we went over for chapter 1. Use of the command window. So, this was like first day stuff when we started going over Matlab. Went over basic math operators like, addition, subtraction, multiplication. Went over precedence, so really just PEMDAS. Then we went over how to make a row vector, a column vector, and a matrix. And we went over how to define an evenly spaced array. Went over polynomials and finding the roots. And then saving the workspace, creating a script, linear algebra, and then intro to plotting, which we just did now. Okay, so I'm going to get my other slides in here. So again, these slides are on Canvas. I uploaded them, I don't know, sometime late last night. So I'm going to save this script, and I'm going to make a new script now for chapter 2. So I'll call this EGME 205 Arrays. And put week 3. Okay, so we always started off with clear and CLC. And if I try to run this now, it'll actually prompt me to save this script. Okay, there we go. Okay, so we're going to be going over a 1D array and a 2D array, so a matrix. And later on, we're actually going to go over a multi-dimensional array as well. So that's basically a lot of matrices in one kind of container. Okay, so we've kind of discussed what an array is. So an array is just a collection of variables or numbers in Matlab. So we can have that as a vector, or we can have it as a matrix, or as I just kind of referenced, we can have a multi-dimensional array as well. So there are different types of arrays in Matlab. So we have numeric, so numbers, logical, that'll be like basically true or false. A structure array, we have Java, characters, so characters are just basically letters or numbers. We have a cell array, so a cell array is actually going to be something important later on in this chapter, so we'll be going over that in depth as well. And then we have also a function handle. So a lot of the stuff we actually aren't going to pay too much attention to, but we're going to focus on numeric arrays and cell arrays mostly for this chapter. So we're going to start out with numeric arrays, so just numbers. So from what we've done previously, we know that we can create a vector in kind of two different ways. We can have a column, or a comma, sorry, or we don't need to use a comma. So if I want to make a row vector A, let me make a section here. So review on vector generation. So I can make our vector A like 5, 2, 3, 3, 4. If I run that, then we see it in the workspace. Or I can put in commas if I prefer that as well. And it'll be the same exact vector. Okay, to create a regularly spaced row vector, we went over this earlier today, so I'm not going to go over it again. But remember, we can use our colon notation, or we can use the Linspace command. Okay, so we can create a column vector by using our semicolon. So let me actually, I'll do this. Row vector and column vector. So you'll see I'm going to try to use a lot of comments like this because this is good practice, especially once we get to the project. You're going to want to put in a lot of comments throughout your script so you can look at your script at a later point in time and be able to easily see what you're doing throughout the code. And it's also going to help me out to see that you guys, and what's going to help me to actually read your code. Okay, yeah. What button did I use to run it? Yeah, the green button up top here that says run. Make sure you're in the editor window. Or you can press F5. If you're on a Mac, you have to press, I think, function and F5 at the same time. Okay, so a column vector, we're going to use a semicolon to make our new row. So I can do B equals 3, semicolon 4, semicolon 5. And then I'll go to the command window now, and I'll look at this output here. So I type in B, and then we see our column vector. So we can create column vectors differently as well. Well, even row vectors or matrices too. So let's say that I kind of want to visualize this column vector in my script. So I can do C equals, and then I'm going to put in my left bracket here. So once I put in this left bracket, Matlab will know that I'm trying to define some kind of array. So I'll put in a left bracket, and then I can go on a whole new line here, and I can put in 3, go on a new line, put in 4, go on a new line, put in 5. Then on another new line, I can put in that last bracket. So if I run this and I type in C in the command window, then there we go. We have our column vector still. So this could be something that you want to do. Personally, I would advise against it because, imagine we are making a really long column vector. It's gonna clutter up your script. Yeah, it looks kind of weird to me personally, but for some people it might be a better way to visualize it. But you'll get used to using a semicolon to make these column vectors. Okay, so when we make arrays in general, the order is often important. So I think back to when we solved that linear system of equations earlier today. So we were solving for x, y, and z, and we were solving for those based on the order that we defined our matrix A earlier on. So just keep in mind that order is important. So in this example here, imagine that this was a vector that actually stood for 5i plus 7j plus 2k. So when you have some order, just make sure that you're consistent throughout your script. Okay, we're also going to use array addressing a lot in this chapter. So a little preview, and we've done some of this before actually, but we never explicitly said that it was array addressing. So array addressing is simply specifying some index in our array. So remember, if I want to look at, let's say, the third value in our vector A, I can just type in A and 3. So I'll say third equals A3. I'll run it, and then you see that that value is 3. And if I look at our vector, that's correct. So let's do it with a matrix as well. Okay, I'll say vector matrix. So earlier today, we used the numel command to, or actually, sorry, not the numel command. We did the same kind of index that we did here. So let's make a matrix. I'll call this capital A, 2, 0, 2, 0, negative 5, 10, 3, 3, 9, 8. Doesn't matter. Okay, I'll press enter. I'll type it in the command window. So let's say I want to look at the 5th element in this matrix. So remember, we kind of go column by column. So we're going to go 1, 2, 3, 4, 5. So the 5th element in here should be negative 5. If I go in the command window again and I type in A, so capital A and then 5, then we get negative 5. But really, we should be more specific, especially once we get very large matrices. Doing something like this, we would have to kind of count it ourselves first. That's not really ideal, right? It's not efficient. So what we really often do is specify the row and the column that we want to look at. So in this case, we know that we're in the second row and the second column. So if I want to specify -5 here, I'm going to use array addressing. So I'll say, I'll call this fifth equals. So we're going to say capital A to look at our matrix, and then the second row, comma, second column. And remember, with this notation, it's always row, comma, column. So now if I run this and we look at fifth, that shows -5, which is the correct value. Okay, any questions on array addressing? Okay. So there was a question earlier if we can append vectors and append matrices, that kind of stuff. And the answer is yes, we can. And we're probably going to do this, you know, in some examples throughout the class. And you're probably going to have to do something similar just in general when you're using Matlab at some point. It's going to come up. So I'll make another new section here. And I'll call this Appending Arrays. Okay, so in this slide here, we can define a vector called A and a vector called B. And if I want to make a larger row vector, from those row vectors, we can append them. So I'll just put some arbitrary vectors here. I'll say M equals, and I'm going to put a row vector right now. Say 20 to -10, sure. So there's one row vector. We'll make another row vector here called N. And I'll make this 100, 34, and pi. And we'll add another, I'll put 4. Okay, so let's go in the command window. I'll type in M, comma N, so I can see the output for both of these row vectors. Okay. And if I want to make a new row vector that contains both of these row vectors, I can do that. So I'll say, I don't know, P equals, and to append these, let's say that I want to append row vector N to row vector M. I will first put in M, and then I'll put in a comma, and then N. So because I put in brackets here, Matlab knows that I'm defining some kind of array. And in this case, it'll be a new row vector that starts out with row vector M, and then it finishes off with row vector N.
I was asking how you append individual elements to an array.
Putting like towards the end, so if you want to
Yeah.
append it, I could just put in like I can put in 5 then.
Oh, okay, thank you.
Okay, so let's run this right now. M comma N. And so it ran, so I didn't suppress the output, so we could see it in the command window. It still looks a little weird just because of the length of this vector. So we can look at it in the workspace over here. So I'll open that up. And here we go. So we have row vector M here, and then row vector N right there. Okay, so there's a question for what does appending mean? So that just means putting, in this case, we're appending this row vector N to row vector M. So that means putting it after that row vector M. And we could also append it, you know, kind of below, and we would make a matrix. So I'll show you how to do that too. Yeah, so we can do it for column vectors as well. And then we can, as I was just kind of hinting at, we can use like 2 different row vectors, and we can make a matrix from those row vectors as well. So first we'll do it for column vectors. So I'll append a column vector to another column vector to make, you know, a bigger column vector. So let's make a column vector A. We'll say 3, 0, 2. And a column vector B. We'll say 10, 20, 5, -4, 9, whatever. All right. So I can take these. Let's first look at them. So we have A, and then we have B. So I can make a whole new column vector from these by appending them again. So maybe this time I want to have column vector B be the first one. So I'll put in B, and then I could put a semicolon and then A. So we're going to have a whole new column vector here that starts out with column vector B, and then appended to that will be column vector A. So if we run this, I'll type in C, and here we go. So we start out with column vector B right here, that's highlighted, and then we append to that column vector A. Okay. Okay, so this is a good question here. So look at this slide. So given these column vectors A and B, what's going to happen if I append them? If I append column vector B to A with this kind of notation here with a comma. So you can either put it in the chat or just say it to yourself. Okay. Okay, so we have two column vectors. We have 3, 0, 3, and then we have 4, 3, 1. So we're not going to create a new column vector here. We're actually going to create a matrix. So let's go over why this is. So first, let's see. I'll call this, I don't know, making a matrix with column vectors. Okay, so we have a column vector A, which is 3, 0, 3. Then we have column vector B, that's 4, 3, and 1. So if we look at this, we have two column vectors, and they both have a length of 3, so keep that in mind. So I can make a matrix with these column vectors by appending these column vectors kind of side by side. So I'll put in A and then a comma B. So this is first putting our column vector A, and then we're appending column vector B. So because we're appending it with a comma here, it's going to put that column vector B basically to the right of column vector A. And then we make a matrix. So before we put a semicolon, and that made just another larger column vector. But if I put a comma here, we're going to get a matrix. So this isn't going to work if I had vector B here, if I had another value here, let's say like 5. Now we get an error because these lengths are different. So it's trying to make a matrix where, you know, our first column is 3, 0, 3, and the second column is 4, 3, 1, and 5. So because they're different lengths, we can't do that. You know, because that just want to be a matrix. So if this value was empty, I would instead have to put a 0 there. And then I could make that matrix. Okay, does that make sense to everyone?
Yeah.
Yeah.
Okay. So another command that'll be useful is the size command. So we know the length command and we know the numel command. But if I want to look at the dimensions of some matrix, I can use the size command. So I can type in size of C. Really, I should have put a capital C here, just for the correct convention. So let me run this. Okay, so I can type in size of C, and then the answer is 4 and 2. So, you know, remember for matrices, we always have the rows and then the columns. So this is telling us that the matrix C has 4 rows and 2 columns, which is what we see here. All right, let's take a look at this now. We have another question here. So we have 2 row vectors R and S, and they both have a length of 4. So if I append them in this fashion, what do you think will happen? So keep in mind the exercise that we just did. So chat, Mike, or to yourself.
You can add them because it's wait, you can't because you're trying to make different columns, but they have different lengths.
But the lengths are the same here. We have 4 elements.
Oh, okay. Then it is gonna work. Okay.
Yeah, so we're going to make another matrix here, basically. We're basically appending or making a new row. So let's go over this too. So making a matrix with row vectors. Essentially what we're doing is kind of like a long-winded form of how we've been defining matrices, you know, up to this point. So before, when I made a matrix, I would use something like 3, 0, 3, 2, 2, 3, 0, 10, 9. And what we're doing in this current exercise is basically defining each row first, and then we're appending them to make the matrix. So we'll do R equals 3, 4, 5, 6. S equals 7, 8, 9, 10. So we have 2 row vectors here, and all I'm doing is, again, kind of like a long-winded form of making a matrix here. So I'll call this, I don't know, Z. And we can make a matrix here that's 2 by 4, so 2 rows and 4 columns, by appending one row vector to the other. So in this case, I'll put R, that'll be the first row, and then I will append to that row vector S. And if I run this, and I type in Z, then here's our 2 by 4 matrix. I also want to quickly touch on, I can put a 0 in front of that 6, and it's still going to be the same thing. It's still a 6. So that might be useful because it's kind of easier to see that, you know, what we're doing here. But just kind of an aside, you can put a 0 in front of a number like this, and that value is still going to be 6. All right, so 2-dimensional arrays, that's just going to be a vector because we have 2 dimensions. We have rows and we have columns. So, you know, kind of like I was just talking about, before, we've been defining matrices as have it in this slide here. So I won't go over that again, but basically, instead of defining row by row like we did in this example here, we can just define this matrix on that one line, kind of like we did in this slide here, and how I've been doing it mostly throughout the class so far. So as you saw before, when we made a column vector and we kind of had that weird kind of formatting, we can also make a matrix this way too. So again, it's up to you. Personally, I don't really like this method, but if you want to go for it, you can. But yeah, up to you. It looks kind of messy to me. So I'm making a matrix on, I don't know, I'll call this like a continuous line. Continuous line. So I can do B equals 3, 4, 6, 7. So I say continuous because Matlab will read, even though I have multiple, I'm on different lines here numerically, Matlab is going to read it as one kind of line. So then I can put -2, 20, -10, 2. We'll go on the last line now, 3, 9, 18, and 7. So if I run this, it works. We can make a matrix this way, but again, it's a little weird, but you can do it this way if you prefer it. Okay, so any questions so far? All right. So, so far we've been defining matrices row by row, which I recommend because, as you're going to see now, when we try to define it column by column, it's kind of a pain in the ass and it looks terrible too. So let's do this. I'll make another comment here, making a matrix column by column. So if I want to make this matrix B that we just defined, but instead, here I did it row by row, I'm actually going to change the formatting here just so it's more what most of you are probably going to do, which is on one kind of line here. So here we're defining this matrix B row by row. So we define the first row, we put a semicolon, we go to the next row, put a semicolon, and we go to the last row. So if we want to define this instead of row by row, column by column, we can do that too. So intuitively, you might think, okay, I can just do 3, -2, -2, 3. And then, you might think, oh, I could put a space, or oh, I could put a comma to go to the next kind of column here. And then 4, 29, put a comma, 6, -10, 18. See, it already looks terrible, but let's keep going. 7, 2, and 7. So if I run this, it's going to give us an error because again, there's issues with our dimensions here. So if we really want to do it column by column, we can, but basically we're like appending column vectors on this one line. So up here we made 2 different column vectors, A and B, and then I from those created column vectors I appended them like you see on line 43. So basically, if we want to do that on one line, we can do it, but I have to wrap each column vector in its own set of brackets. So the first column is 3, -2, and 3. Let me count this out really quick. I'll run B. Okay, yeah. So we have 3, -2, and 3. And then I can put in a comma, and then I can define the next column, which is 4, 20, and 9. Put a comma, now we're in the next column, 6, -10, 18. Then we have 7, 2, and 7. Okay, so I just ran it, and now it runs correctly, but I mean, look at this line. It looks terrible compared to the line up here for B. So if you're crazy, you can do it this way, but I think it looks terrible, and it takes a lot more time too. So that's why I usually define a matrix kind of row by row. It's a lot easier and cleaner to type. Alright, so the transpose operation. So I briefly talked about this operation before, but we'll go over it in a little more depth now. So the transpose operation, I guess you maybe only know about it if you took 250B. I don't know if you learned about it in any other math class. But basically what that transpose operation does is it swaps the rows and columns of a given array. So it doesn't matter if it's a row vector, a column vector, or a matrix. It's going to swap the rows with the columns. So it'll kind of like, flip it like that. So in Matlab, to use this transpose operation, it's going to be a single apostrophe. So make a new section and call it transpose operation. Okay, so let's transpose a row vector into a column vector. So I can do A equals 20, 30, 40, 50, and then I'll do 13 just to ruin the pattern. Okay, so I have my row vector here, A. And if I want to make this column vector, all I have to do is I can put an apostrophe there to transpose it. So let's go back here. So now if I press enter, then there we go. We have a column vector. So I could have also made this column vector by doing 20, 30, 40, 50, 13. So I could have done that. And this is very valid too. But it's actually kind of faster to first make a row vector and then transpose it to make a column vector. Either method is totally valid, and I use both methods, often. I actually probably typically use this method here on line 58, but line 57, it is faster, but you need to make sure that you remember that you transposed it with that apostrophe at the end. And then same thing with the column vector, we can transpose that to make a row vector. So, here on line 58, I made a column vector, but I can use the apostrophe to make it a row vector. Okay, and then if we do it for a matrix here, this, I guess, if you're seeing it for the first time, you need to kind of look at it a little bit to really see what's going on. But just remember that we're flipping the rows with the columns. So I'll put a little % here, make a comment on a matrix. So I'll make a matrix 2, 3, 2. That's fine. 9, 8, 7, 3, 5, 4. All right, here's our matrix. So we have it like that, and I'll go on a new line here, and I'll say B equals A and then transpose. So we put in that apostrophe. Now if we run it, let's make this a little bit bigger. So we have A here, and then down here we transposed it. So remember, that's flipping the columns with the rows. So you can kind of see it here. Here we have 9 and 3, and they swap places. Here, along this diagonal, we have 3, 8, and 2, and they flip. 8's going to stay the same because that's, kind of the origin that we're flipping about. And we have 5 and 7, and they flip as well. And then on the ends here, 4 and 2, they stay in the same position as well. So using the transpose operation, we don't use it too often. Mostly it would be like in a case like this where if we wanted to find a column vector from a row vector, but we do use it sometimes, so it's definitely something that you should know. And especially for math, you're going to use it for like a math problem actually a lot, like in 250B. Okay, so we have a little exercise. So given these following row vectors, how can we create this matrix A? So I'll just go over it because I don't know, it's pretty simple. So we're going to append them and transpose them, so kind of a combo. So transpose operation exercise. So we have two row vectors, R and S. Let me suppress these outputs. Okay, so we have 3, 4, 5, 6. And then S is going to be 2, 2, 0, 2, 4. Okay, so here are the row vectors that we have, and I want to make this matrix A. So basically, I want this to be a column vector, and then I want to append this row vector S, but also make this row vector into a column vector. So to do that, we're doing both transpose operations on these row vectors, and then I'm appending row vector, or the vector S, to the vector R. I don't know, transpose matrix. Not a good variable name. I'm not going to do it. Okay, let's do capital Y. So we're going to first transpose R. So we'll do R apostrophe. And then I'm going to put in a comma because appended to this now column vector, I want to put in the column vector S. And then we'll run that. And then here we go. Here is our matrix. That's a 4x2 matrix. All right, everyone clear on this kind of operation here? Okay, yeah, so there's a comment or a question. if I instead put a semicolon, would it just go straight down? So yeah, in this case, it would just make a column vector because we basically have two column vectors here because we transpose them. Okay, any other questions on this? Okay. Yeah, this is from before. We're in week 3 already. So, let's see what's next here. I think I'll probably stop here. Yeah. Okay, so I'm gonna stop there, but I would also like to say that I think, at least I don't know, I get the feeling, correct me if I'm wrong, but I know some of this stuff is a little bit tedious so far. Just because we're still learning the basics in Matlab. But once we get to the plotting chapter, and then after that we start doing programming, so with for loops. Hopefully the lectures will be a bit more interesting because I like to implement some examples that are a bit more like real life examples. So instead of having some arbitrary numbers thrown at your face and I'm telling you make this matrix and this vector and transpose it because why not? We're actually going to have some more real life examples. Like I often use baseball data, so if you hate baseball, sorry, but I like to have more real life examples, so you have more of a motive or an interest in completing the examples. Okay, question. Did I see a quiz 1 on a slide? I don't know. Did I? Oh, yeah. Well, this is from last semester, so I haven't updated all of these slides yet. But your first quiz, since that's actually kind of brought up now, I won't have you do it until after the homework is due. So I would have liked to have it next week, but or this week rather. But your homework is due this Wednesday, and I'll probably have our first quiz on the following Wednesday. But I'll send out an announcement. All right, so that's all I have for today. There's one more minute, but that's all I have. So if you have any questions, stick around. But if not, I'll see you next time on Wednesday.
Patrick, I'm just like, Patrick, what if you're like lost the entire time? Like,
Yeah.
sorry, this is sorry. Like,
No, you're
it's
fine.
like, yeah, coding's not my specialty. That's the reason why.
Yeah, if you have any questions, you can, if there are, just a few questions, you can stick around now, or really I'd recommend you go to office hours tomorrow.
Yeah, that's the thing. That's the thing. Like, your off. Yeah. So I was going to say your office hours. Your office hours not provokes, but it like contradicts like my Tuesday schedule.
Okay, yeah, we can meet up some other time too. We just have to work
Can
out a
you
time.
do appointments if I really need help on it?
Yeah.
Okay.
Yeah, just send me a message in the Discord, and we can.
All right, I'll like send you I'll send you like a Discord message if I need an office hours.
Okay.
All right.